Welcome back to part 6 of the Stockpot 2 refining series. What a difference a day makes. I reviewed part 5 of my video and I learned some important things just by watching my own video. This is footage from part 5 of the Stockpot 2 refining series. And I was reviewing part 5 last night, 2 a.m. And I came to this part and realized that that solution is perfect, just like it is right there, for addition of some zinc metal to precipitate out the platinum group metals. Now, in my previous refining series for the Stockpot, I had a problem with copper. And I don't have a problem with copper with this solution here, because if I did, it would be green. So adding that DMG was the incorrect thing to do here. As you can see from that last clip, I should have put some zinc in that concentrated solution and got the platinum group metals out with zinc rather than with dimethylgloxine. And I think I would have been a lot better off, but no further delay here. Let's get right into it. Part 6 of the Stockpot refining series. Let's start out with a review here of where we're at with all this. This is some gold down in this melt dish. And I'm going to move this over on the melt table, just get it out of the way. And right here we've got some palladium in solution that we concentrated with DMG in part 4, I think it was. I can't remember, I'm getting ahead of myself. This is some more of the same solution that we used zinc to precipitate out the metals. Still got that. And then this was a third extraction. We tested this in part 6 or part 5. Determined that we've got metals in solution. Set this over here out of the way now. And we're going to bring up the last thing that we worked on in part 5 was the solids in this filter. And I've got some solution down here that I filtered. It's got some kind of precipitate that's come out of solution there. So we're going to start with this. We're going to work with this stuff here first. What I want to do is get the solids and the filter into this beaker here, out of this funnel, and let's get the solids out of this filter into this beaker. And now what we're going to do is add in some hydrochloric acid. Not very much, just a little bit. Nitric acid. Add a few milliliters of nitric. And then we're going to turn the stir bar on. Turn the stir bar on here. Cover it up. Some heat on. We're going to let that redissolve. See if we can do something with these solids. Now what we'll do is transfer the solids out of here, out of this flask. Filter all that stuff that's in there. I'm going to filter it out through this filter flask here. Add a filter paper. Cut the vacuum on. Solution from this flask through this piece of filter paper. Got a little bit of solids in here trapped in the precipitate down the bottom. if I can get this out of here. I looked over here and noticed I got a boil over just waiting to happen. Just lovely. Just lovely. Doing it on camera too. Okay, this calmed down. I'm gonna take this. We're done with this. This is going in the stock pot. I'm not messing with it anymore. Put this filter, it's got some solids in it, put it in here with this group of material and try to get everything to dissolve. Alright, I wanted to test my theory about cementing the metals out of here with zinc, but that would require me to evaporate this solution down, spend 2 or 3 hours getting all that liquid evaporated out of there. If you look at this Stannis test, it's just a very small quantity of platinum in there. And my urge is to go after it and get it. But my lesson from my last video is get rid of it, get it in the stock pot, get it out of our hair, and move on. Alright, here's a waste container that I have. Let's see here, how are we gonna maneuver this? I'm glad when I get a new fume hood that's bigger. I'm gonna pour this into the waste solution. I mean, I'm not wasting any more time on this. I could try to recover this metal out of this solution by adding zinc, but it would make a real fine precipitate that didn't settle very well and just too much to wrestle with for the small amount of metal that it contains. These are the kind of solutions that are suitable for addition into the stock pot. Okay, that's done. This is dissolving. This should be some good clean metal that we can work with. I'm gonna move my waste flask out of the way here. Bring up another filtered flask. And what we'll do, pull the solution out of these solids that we did a third extraction on in part 5. Here we go. We're going to pull the solid, or separate the solids from the solution here that we did in part 5. Solution looks pretty good down here. We should have some gold in there like we did last time. And now what we're going to do is get the rest of the solids down into this filter. Hit them again with aqua regia all day long until everything that will dissolve gets dissolved. Got the solution pulled through this. You can see there's just very little solids left in there. Some black powder. Take this and set it off to the side. Now we're going to transfer the solution out of here into a clean beaker. going to rinse with water anymore. Using water on these platinum group metals tends to change some value in there, and I want to avoid doing that. I'm going to set this off to the side over here, and we'll get this beaker back up front. Transfer the solids back into this beaker. I'm going to add a little bit of hydrochloric acid again. I filled it up to about the 200 milliliter level there. Give it a splash of nitric acid. And then we're going to put this up on the heat and let it react, do a fourth extraction on those solids. Alright, let's bring this solution back up. This is going to have precious metals in it. This beaker here, I chose the wrong beaker. I should have used a tall beaker, even though it had just a little bit of material in it. Try to add some nitric acid to make sure everything gets dissolved here. Just a few drops. This had dimethylgloxime in it, and it might still be present and trying to precipitate out metals in this solution. So I'm going to try to get everything to dissolve by adding some more nitric, form aqua-regen there. I got to be honest with everybody, doing this on video is nerve-wracking. I'm using unfamiliar processes here. That looks like gold. So what we'll do is we'll add some sodium metabisulfite to this solution. Precipitate out the gold. Here we go. Yeah, doing this stuff on video is just nerve-wracking, man. It's just, I'm concerned about time, not getting too long with each of these shots that I'm trying to include. I don't know what's going to happen in some of them, and so that uncertainty, like that uncertainty creates a situation that's very stressful on me. All right, now we're going to do another status test here. All right, let's see what we got in there now that we've added the SMB. Get a little bit on our filter paper. Do another status test. And now all the brown is gone, most of it anyway. We still got a little brown going on in there. Let me add another squirt or another spoon of SMB just for good measure, make sure we got all the gold out of here. Looking for that foaming action like that. Tells me all the gold has been dropped out of here. Of course, keep in mind that SMB will also precipitate platinum group metals if they're present, especially if there's excess nitric in our solution. Okay, let's get another status test here. See what we got. And that's green and orange. Looks like we got all the gold out of there. And all that's going to be left is the platinum group metals. That's a good thing. Alright, I think this is completely dissolved now. Turn the heat off, the stir bar off, and let this settle. Here's the gold that we just precipitated out of our extraction of the solids. Looks like a respectable amount. Back here I've got my fourth extraction going. Going to have some lunch now while all this stuff settles, and then we'll come back out and get it again. Wanted to show one more thing. The current flow through the cell has slowed down to a crawl. You can see the slimes in there in the anode filter basket have impeded the flow of current. If you look in here, we've got a bunch of silver crystal in here, and I'll have to clean this out today and then restart the cell with a fresh anode filter. I'm going to start out by rehydrating our reaction in the back there. It's about 100 milliliters of hydrochloric acid. I'm going to add this here. Now I'm going to add a shot of nitric acid to our solids back here and let that continue to react. In the meantime, we're going to see our gold is settled out nicely in the bottom of this flask or this beaker. And I'm going to stick a piece of paper down here, filter paper, get some of this solution on it, test it with some stannous chloride, and you can see we've got platinum and palladium in solution, it looks like. I've got a second test strip here. I'm going to stick that in here. Do a stannous test on that, and it's got, looks like, decent amount of platinum and palladium in solution also. So now what we'll do is I'm going to take and set up a filter here, and we're going to filter this gold out of this solution right here. Got a filter set up here. Find a place to set this down for a second. Connect my vacuum hose here, and let's go ahead. Looks like I got a pretty decent separation of the gold from the platinum group metals here. Some of this stuff out of the way. We've got our gold up here in this filter now. Here's the melt dish with the gold from the last two extractions. I'm going to add it to that. It's not very much, but it's enough to save, and put it in our melt dish here. We're just going to have to burn this off here a little bit. Now what we'll do is I'm going to filter the solution that we just dissolved here, adding a filter to this. And now we'll pour this solution in, collect it down in the flask. Here we go. Here we go. We're gonna go for the platinum group metals in this solution. I'm gonna pour it into a 2-liter beaker, and we're gonna heat it up on our hot plate here. Try to get this solution concentrated. And then we'll test a sample of it and see what direction we need to go as far as precipitating these metals out. This way down, and I've got some precipitate, some compound forming in there. Wonderful. Get a status test here. You can see we've got plenty of platinum group metals present. So now what I'm going to do here is I'm going to add some hydrochloric acid, see if we can get this precipitate to redissolve. I don't know what it is. And we'll put some hydrochloric acid in, see if we can get that to go back in solution. If we can't, I'll just filter it out, and we'll work with the filtered solution. All right, let me turn the heat off here. We're gonna let this cool down. And I'll get a filter set up. We'll filter this solution. All right, let me take this down off the stir plate so it can cool down. I'm gonna reach in here. This has been on cooking all day again. Get a little bit on the filter paper here. And we're going to do a status test on this now. See what we got. And we got a little bit more platinum group metals in solution back there. Add a quick shot of nitric acid back here. Keep that reaction going. All right, here, let's go ahead and get this thing going. I'm gonna swap this 500 milliliter flask out for a 1 liter flask. And what I'm gonna do now is I'm gonna filter this solution first. And then I'm going to filter the solution back here in the back, both into one flask. This one here from the DMG precipitation and redissolve. And don't think there's any need to do it with this one. This here's going to be a clean platinum and palladium solution. So I'm just going to filter both of these solutions into this flask. And then we're going to start precipitating the metal out with zinc. Here we go. Precipitate is. I'm not going to worry about it. It's going to go in our paper storage. And we'll worry about that at another refining. Sure what that stuff is in the filter. Pretty much got it all pulled through the funnel now. And what we'll do, we're going to transfer this solution into a clean beaker and then add some zinc. Should be a nice clean solution now. We're going to add some zinc and precipitate out the platinum group metals out of this solution. Let me pull this funnel off of here, get it out of the way. Now I'm going to transfer this solution into a clean beaker. Rinse it into my stockpot. I don't want to dilute that solution any more than it already is. Alright, now I'm going to start adding some zinc to this thing. Get those metals cemented out. Here we go. First piece of zinc going in. Should react fairly vigorously. Alright, we got that metal dissolved, and zinc is dissolved. We got the platinum group metals that came out of solution here. They're on the bottom of the beaker. And I'm going to add this group. It's the same thing. Pieces of zinc in it. I'm going to add it to this main beaker. It's got our black PGMs with it. Cemented out on zinc. In fact, there's a few pieces of zinc in here. See if we can get them out of there. Rinse this out with a little hydrochloric acid. Get it down into the beaker. Alright, that'll do it. Rinse this little bit of solution out of this flask with a little bit of hydrochloric acid. Add that. Now we'll just let this react until all our PGMs come out of solution. These reactions are so interesting to watch. How the metal goes into solution, the zinc goes into solution as the platinum group metals come out of solution onto the zinc. I know it looks pretty neat there on the camera, but it doesn't compare to what it looks like in person. Here's the metal we got cemented out. It's not very much, but I'm gonna have to get it out of this solution, or it's gonna try to want to go back into solution here. All the zinc has been consumed out of it. First, we're gonna go ahead and shut the heat off on our extraction, our fourth extraction back here. Let that cool down, and now we'll get the black mixed PGM powders out of this solution. Get a little bit of this solution on a piece of filter paper. I'm going to test it for the presence of precious metals. Shouldn't be anything in here. And as you can see, the solution is completely void of precious metals. Alright, now we're going to take and rinse the solution off of here. I'm going to pour the solution off into a waste container, and then we're going to rinse off the black mixed PGMs in this container. We leave this acidic solution on here, those metals will want to try to go back in solution. Now what I'll do is I'm going to use some just regular old tap water here to rinse the acidic solution off of our black PGMs. There's our fluffy black metal down there. I'm going to rinse this off right quick. These metals are just weird. Some of the toughest, most stable, non-reactive metals in the world. You let them set in a little bit of hydrochloric acid solution and they'll redissolve. Unbelievable. Cover this up, and set it off to the side. It's safe in that tap water. What we'll do now is we're going to get this solution and get this filtered and see what we got in solution here. All right, let's filter this solution out of here. This is our fourth extraction of the solids. All right, this is still hot. That should be okay. It's late. I'm getting in a hurry. I should have let that solution cool off a little bit before I tried to pour it through that filter. You'll see at the end of the next clip coming up here, the filter paper fails and everything just flushes right through the filter, and I gotta start all over again. Well, the filter failed on me there, so I prepared another one. What we'll do now is got to refilter the whole solution. This little bit of black powder that I got left in here, that will just go into my paper storage. All right, here we go. We're going to start the filtration process all over again. Here I make another blunder. I overfill the filter paper and some of the black material gets down into the filtrate in the flask, and I gotta start it all over again. We'll get a little bit of metal out of here, down into the filter. And if you notice, down here in my filtrate, I overflowed the filter. I've got some black particles down in the solution. So what we need to do is refilter this one more time. All right, while I'm waiting for this to pull through the filter, I'm going to reach down in there and get a little bit of solution on the piece of filter paper. And get another status test real quick here. As you can see, we've got metal in solution, so there's going to be some values in here in the solution that we need to extract. All right, this is about a minute after I did that test. You can see there's some green color down here and some orange up here. This is going to be mostly palladium and platinum in this solution. I don't think there'll be much gold in there after all those aqua regia treatments. All our gold should be out of there now. Alright, I might be screwing up here, but I'm going to try to pull this filter. Still got some liquid in it. Transfer it into this thing. Now we'll put a new filter and get these solids out of here. Alright, here's a new flask. Put this funnel. Rinse it out. We'll put this funnel in a clean flask. Got another filter paper here, and we'll filter the solution one more time. I poured it in too fast. We got some black particles in here, so here we go with the third filtration now. Okay, I think we got everything pretty much classified up to this point. This is going to be a little bit of the black material that's left over from the hot aqua regia treatments. There's some black material in here. This might be rhodium or iridium that does not dissolve very well in aqua regia. I'll save this filter for some later experiments. This solution here, got it pulled through now. What I'm going to do is add this to a beaker. We're just going to cement the precious metals out. Should not be any gold in here. Should all just be platinum group metals, palladium and platinum in here. All right, let's add this to a clean beaker. And I can see some light at the end of the tunnel on this thing. Now we're going to put some zinc in here and cement the metals out of this solution. Highly acidic, as you can see. Waiting for this to get done reacting. I've got our melt dish here. It's got the gold in it that we recovered, and we're going to melt this up and try to get a little button out of this now. Here I'm adding a little borax to help keep the filter papers that have particles of gold on them from flying out of the melt dish as I do this melt. Look at that fire, man. There's just something primal about using torches to melt metal, especially when that metal is gold. That material that's being burnt in the melt dish there is throwing off some pretty bad fumes. So I've got my mask on, and I'll keep it on for the rest of the video here. So I'm going to have to kind of talk you through some spots. That'll be coming up. Alright, here's the button that we just melted. It's going to be heavily contaminated with platinum group metals, but it is gold. Throw it up here on the scale, see what we got. It's 3.7 grams. Here's the other button that we got from the previous gold recovery video in this series. So we got a total of 7.6 grams of pure gold from our stock pot. Here we are back out at the fume hood, and that is the material that we precipitated with zinc from that final extraction of the solids. And what I'm doing here is I'm pouring off the waste solution. The waste solution will be acidic, and if it's left on top of those solids, they will redissolve. So I'm using tap water here to rinse the acid off of the metal so it stays precipitated and does not redissolve. That waste that I'm pouring off into the flask there, that will be added to my new stock pot. It will contain a few particles of precious metals from that rinse water. And now here I'm adding this little bit of metal into the main batch. And now here what I'm going to do is I've got both groups of metal combined into one flask or one beaker there. I'm pouring off the water. And now I'll transfer the mixed black PGM powders into a 400 milliliter beaker that has the weight of the beaker written on the side of it there. 191.2 grams is the weight of the beaker by itself. I pre-weighed that earlier. And here I'll do multiple rinses to get the rest of the acid rinsed off of the metal. There's going to be a little bit of zinc in the metal from the cementation process. We used zinc to cement those metals out of solution. So by rinsing off the black PGM powders there, I'm rinsing off the acid as well as the zinc. Here I've got some pH test strips, and I want to get a general idea of what the pH of the rinse water is to determine how much more rinsing I need to do until I've got all the acid rinsed off. I'm looking for a pH of 7, neutral. That last pH test was around 5, between 5 and 6. And so now I've done 2 more rinses. I poured a third amount of water on there, and I've got some more accurate pH test strips here. And what I want to do now is get an accurate reading of what the pH is to see how close I am to getting a pH of 7, which is neutral. And the theory is there that if I've got all the acid rinsed off, I've got all the zinc rinsed off as well. And you can see I got a pH of 7. This is the final rinse of the mixed black PGMs. I'm pouring off as much moisture as I can. And now I'm going to put it up here on the hot plate and put some heat to it and evaporate all the moisture. Evaporate the powder to dryness. Here we go, our platinum group metals are bone dry in there, so you can take it in now and get a weight on this. All right, let's see what we got here. We've got 196.5, so 196.5. That means we've got 5.3 grams of platinum group metals in here. Mixed black platinum group metals. Okay, let us do some ciphering here. Put our gold up on the scale. And we've got 7.6 grams of gold. Now we're going to look at my phone here, and I've got a site that I go to. It's called Kitco, and they give the price per gram of the gold. If we were selling, we'd be asking $57.12. If we're buying, we'd be buying it at $57.09. So I'm going to use the bid price here, the lower price. So we got $57.09, 57.09 times 7.6 equals, that's $433 worth of gold. All right, let's take these down and look at our platinum group metals. We've got 5.3 grams of platinum group metals. I'm going to call it platinum because platinum is, look, it's half the price of palladium, but I'll probably have half palladium and half platinum in here. Won't know until we get to part 7 and I refine it. So I'm going to interpolate, and we're going to call this material about, let's call it $40 a gram for the material in this. That's interpolating between platinum and palladium. So we're going to call it 40. Let's call it 36. Let's see, memory plus. So we got 36. I'm going to interpolate these figures as $36 times 5.3 equals, so there's $190 worth of platinum group metals plus the 433 in gold. We got a total of, right now it looks like, about $624 worth of metals here and here. Okay, this will do it for part 6. We got the platinum group metals and got it all dried out. This is the mixed metal in this beaker. In part 7, what we'll do is redissolve this and try to separate the two, the platinum and the palladium, in part 7. And plus we got 2 little beads of gold out of our stock pot, total of 7.6 grams, not bad. And I calculated here on my little calculator, we got $624 worth of metal so far, it looks like. So this one went a little smoother than the last refining. I did have some problems and some stumbling blocks from time to time here, but we got through this one much smoother than the last series. All right, this will conclude part 6 of stock pot number 2 refining series. Thanks for watching.